Figure 1 shows equivalent transformations of the components in figure 2. So this is your figure 1 right here, right? And we have a figure 2. The two circuits are basically equivalent of each other. Looks like from here they went from the current source parallel to resistor, they went from to a voltage source which is 5 volt to a 2 ohm resistor. So we have to identify the value that most nearly matches the transformed source into the block alongside the current source. So we have to find out this current source, which should be fairly simple, because if you look at this network right here, this part of the network is basically transformed into this series network, and this part of the network is again transformed into the series network of the two components, and then you have this open circuit in the middle right here. So here, if we can just simply apply Ohm's law, where I equals to V over R, that would give us the value for the current source, V being 5 and then resistor being 2 ohms. That is simply just going to give us 2.5 amps, and hence this was pretty simple. We have 2.5 amps of source over here, correct? Let's go down. Identify the value that most nearly matches the transformed resistor into the block alongside the conductance. So we have to find out conductance of this resistor. Looks like this resistor is equivalent to 4 ohms, right? And we know from the previous video that conductance is just simply a reciprocal of R, where R being 4 here. So if I do the math, I get 0.25 Siemens. So this value is 0.25 Siemens right here. And if you look at over here, this was 0.5 Siemens, which means 1 over 0.5 is going to give you 2 ohms, and that's where this 2 ohm came from. Okay, all right, fairly simple.